Hello and welcome to lecture 6.2 on global energy consumption for AP Environmental Science. Telling you I'm wearing my nice cozy jacket. Great way to conserve energy if it's cold is to wear a jacket. I might be taking this off because it's warming up in here. And so we want to talk about how energy is used around the world. You can see that lots of energy is used in the United States and Europe, and not as much energy is used in certain other areas around the world. So global energy consumption is different in different places. It really has a lot to do with the countries being developed or developing, and those energy uses are changing with the demographic transition. So let's talk about units of energy, a little physics for us here. So the basic unit of energy is the joule, Joule. Starts at the unit, we call it a J, all right? So you should be taking notes in your packet on page 2 after you've watched lecture 6.1. So this is global energy consumption. You can see our objectives here to describe the distribution of energy resources in developed and developing countries, to describe the trends in energy consumptions as countries become more developed and the world becomes industrialized, especially with regards to fossil fuels, and explain how availability, price, and government regulations influence which energy sources people use and how to use them. So this is where you're writing this down. So the basic energy unit is a joule. And then you have a gigajoule, which is a GJ. I get those letters mixed up sometimes. That is 1 billion joules. And that's the amount of energy that's in 30 liters of gasoline. So we're going to stay all metric here. Okay. All right. Then an exojoule, which you almost never hear about, but is important for conversions. An exojoule is 1 billion gigajoules. All right. And then the one that we use more often because it is really, we use so many joules, and individual joules is a small unit when you're talking about global energy usage. So we call it a quad in the US, but that's like never used anywhere else. So usually you're going to get British thermal unit. Why not? BTUs. So BTUs is a very common term, and it is 1.055 of an exojoule. Now, don't worry about memorizing these. They will give you these conversions, and most of the time you're going to be in British thermal units anyway. So let's practice some dimensional analysis. Yay! So the question is, in 2011, the total world energy consumption was approximately 521 quads per year. So how many gigajoules is that per person every month? And you're going to show the setup. So I'm going to explain these to you, and you're going to write it down in your packet. And see, I'm getting warm, so I'm going to take off my jacket, which is a good way to regulate heat, right? Oh, I'm going to put my jacket on my legs because then it's like a nice balance, and then I don't have to try to adjust the heat, which I don't have control over anyway at the school. That's another thing. So we are looking for the gigajoules per person per month. So that's what you're going to start with, and you are writing this on your packet. So see, you could pause the video right now and see if you could set things up. And then I'm going to go through the setup with you, okay? So the first thing you're going to start with is those conversion factors from the slide before. So you have 10 to the 9th of 1 billion gigajoules per exojoule, and then 1.055 exojoules per quad. And then given in your question here is that it's 521 quads per year. And then there's 12 months in a year, and then a year per 7 billion people, right? So if you go through and put that into your calculator, you will get the answer. You can pause if you wanted to, And then the answer is 6.54 gigajoules per person per month. All right. So we will be doing more practice. There's lots of math in this unit because that's the idea. How much energy do you need? How can you meet those energy needs? And how can you do it in a renewable way? How can you use energy without using it up? All right, so let's talk about global energy usage. So can you fill in these little blank spots? Where do you think each of the blanks go? And your choices are the countries that are missing there that are going to be below the little lightning strikes are Bangladesh, US, France, Brazil, and Japan. So which of the names of the countries do you fit? Where do you think each one fits as it relates to the energy use per capita on here? So per capita means per person, right? So this is not the energy use total, it's per person. And then obviously the energy use total would be different if you multiplied it by the people. So you can pause this and then I'm going to show you the answers. Okay. So Bangladesh is the one that uses the least energy. And then the next one, Brazil. Okay, now let's see if you get the next one right. Japan is next. Did you get that one right? France. And of course, we use the most energy per person. Part of the problem. Let's be part of the solution. Okay, so developed and developing countries on page 3 is where you're taking notes now. Commercial energy sources are bought and sold, okay? And subsistence energy sources are gathered by individuals on their own immediate needs. So straws and sticks and animal dung, those are things that are being used more in developing countries, whereas developed countries are buying their energy. And there's a different type of energy that's used. So you can pause that if you need to write that down in your notes. Okay, and then it asks, so as industrialization increases, so does the amount of energy. Okay, so you're going to do this graph, and then you'll fill in the top stuff in just a minute. Okay, so you don't worry, you don't have to fill it out exactly. Mine, when I photocopied it, it was pretty light, so it's kind of hard to see the graphs there. So I want you just to think in general, looking at the data that you have there, what would be the x-axis and the y-axis? And what would be the title of this graph? So we're not actually graphing it per se. That is something you could do. But really what I want you to do is just set up for me the x-axis, the y-axis, and what the title of this graph should be. So I'm going to pause and let you think about that, or let you pause. Hi, I'm recording a lecture, so now you're on the lecture. Bye. All right. People are picking up the Unit 6 packets because they're big and I made photocopies double-sided for you. All right. So now that you've paused, here is the answer. So like I said, you don't have to have it drawn in perfectly, but you can just get this idea. Now you could cut and paste this from the lecture, or you could just sketch it in, okay? So as industrialization increases, an increased, as industrialization increases, the energy use increases and the sources of energy change. So instead of being as reliant on these renewables, hydroelectric and or wood and other renewables, you start to become more reliant on oil, natural gas, and coal. Nuclear also goes up as industrialization goes up. So the industrialization increases, energy use increases, and the types of energy change. Okay, so the patterns of energy use. So now you can use that graph to help you answer these questions, all right? So, so what you need to do then is look at this graph and try to answer the questions on page 4. Okay? So pause this, look at this graph, and answer these questions. The predominant use of energy until 1875, all the way through since 2000, what has been increasing. This is a really important skill to have for the AP test because you'll have to look and interpret graphs and answer questions like that. Okay, so pause and answer these questions. And now you're back. So here are the answers. So the predominant energy source until 1875 is wood. At that point, after that point, coal took over. And we really weren't using nuclear power at all until 1950. In 1970, there was a dramatic dip in the oil prices, in the oil usage. And that's actually, you have a video, a little 2-minute video to watch that you can link right there. Okay, so what happened in the 1970s, the energy crisis? There was no gas. We were out. But if we were out, how do we still have more if it takes millions of years for the oil to be produced? So we're going to talk about what actual production of oil means when we get into that chapter. Okay, so watch that little video. The link is in your notes, and you can find that also in the on Classroom. There's a link to this actual doc, and then you can click on the link there. All right, the top 3 sources today are oil, natural gas, and coal. And since 2000, there's been an increase in natural gas, and that's mostly because of fracking. Oh, yes, we get to talk a lot about fracking. Frack. So the increased available due to new technology, and that is fracking. Okay, so now you're going to be filling in the primary energy consumption by energy sources. This data is from 2018. Okay, so go ahead and fill that in and pay attention to the different sources and what we're using, or at least from 2018, somewhat recent. Petroleum, natural gas, and coal. All right, so energy uses vary. So in the Midwest, and Southeast, they usually use coal for electricity. So making electricity as a secondary energy source, we're going to be going into a lot of detail about how different energy sources are used to make electricity. You don't just find electricity. It's not like electricity from the sky, not like static electricity, and not like lightning. We use these energy sources to create the electricity. Okay, so they use coal for electricity in the Midwest and Southeast. They use nuclear and natural gas in the West, and the nuclear, natural gas, and hydroelectric in the West and Northeast. And then in the highly populated areas, they use less coal. So why do you think they use less coal in an area that's highly populated? Because of air pollution. And when there's a highly populated area and you're using lots of coal, they get lots of coal dust and air pollution, and people don't like it and they fight back against it. Okay, so this happened a lot in the Industrial Revolution. The smoke horrible, like in London and stuff like that. So that is the reason for it, because people, when they actually see how bad the pollution is, when it's that concentrated, you push back because you don't want that kind of air pollution. So in the north, uses more energy in the winter. Why do you think that is? Because you need to heat stuff. And in the south, you use more energy in the summer. Why do you think that is? You have to cool stuff. So air conditioning. So one of the things that we can do is we can get really smart about wearing a jacket when it's cold, and finding ways to cool your house besides using air conditioning. So we'll get into ways to talk about reducing the energy use, because conservation is always the best way to go. So energy consumption in the United States, this is where we use most of the energy in industry and building and transportation, and there's residential buildings and commercial buildings. So you can kind of look through this and see how it's broken down on your packet. It's very, very small. So you might need to look at that and write a couple things in, or if the photocopy isn't good, or at least mine's not that great. Okay, so this is how we use the different types of energy. And so why do we use gas or diesel for our cars instead of coal or firewood? Well, here's a little picture of it. The energy mass to ratio is not good. You would need that. You can't drive around with this much wood on top of your car to burn it. So it's very condensed energy. That's what we're going to talk about. Like fossil fuels are basically condensed solar energy. That's how you can think about it. Actually, you really do have solar cars. I'll explain if that doesn't make sense to you, but it's always the sun, right? Almost always. So the energy to mass, you need a smaller volume of gasoline. So that's one of the reasons. Also, it starts quickly, so it can get shut off quickly. Like, it's hard to start a fire and then to make sure the fire is completely out. Whereas with gas, you can turn it on, turn it off, kind of like the gas if you cook with gas range at home. So why not use gasoline for everything? Well, the reason is there's high amounts of air pollution per joule of energy released, and it requires a lot of processing and refining, which is expensive. So refining, so you get oil out of the ground and then you refine it into gasoline, and you refine it into different products to be used, like diesel, all the different kinds of oils that you would get from the crude oil. So that's going to be in an upcoming lecture also. So you can't use firewood for everything, and you can't use gas for everything. And what we're learning more and more is that you can't use non-renewables forever because they're going to run out. So besides them running out, they are affecting the earth in a way that is going to make it non-sustainable for all future generations. All right. So there you go. There's your lecture 6.2. Thanks for listening.